All right, we're back. We are COMP123 in the summer 2017 semester, and we are week 9, part 1 of our broadcast. We're talking about inheritance and polymorphism again today in more detail. I'm also going to be talking about assignment number 4, right? Assignment number 4, which is different than your assignment number 4 that you may have been told about from Narendra. If you kind of go up on eCentennial, all of my assignments will be up online. There are no more paper assignments for me. So it's currently up online and available to you now. I'm going to talk about it. Now, this is very similar to what you may have seen before, and it could be a little different. So last week, before I go into the assignment, we talked about inheritance. And inheritance, before I go into this, what is inheritance? If you're going to say in an interview, I got you an interview, and I'm asking you, what's inheritance? So tell me what's inheritance in your own words. From another thing to a new thing. Use more specific things.
You get a class.
Yes.
And, you get a new class.
Yes.
The new class get an inheritance from that one.
Okay. Don't use it. Try not to use inheritance in your definition. Try to use some other words. Common language. Like imagine if I'm an interviewer and I don't even know anything about computers, but I'm interviewing anyway, which also happens a lot, right?
All right. You have attributes for persons. All right.
Yes.
And all the persons they have 2 legs, 2 arms, and 1 head. Right? There is some.
Hold on, let me write this down. No.
Yes. And then there is some people like me.
Yes.
That I don't have hair. And
that's good. That's good.
And he has hair.
All right, right.
He has everything that I have.
So one person has hair, one person doesn't. Yeah.
Plus hair.
So he's better than you? Is he bigger than you?
Yeah.
Okay.
He's different.
So okay.
So,
Yeah.
we have the person here.
Yeah.
2 arms, 2 legs.
Yeah. Yeah.
And 1 head.
Yeah.
Okay. And we have a new kind of person here that has everything: legs,
arms,
head.
Yeah.
Plus
more hair. Oh, okay.
So he takes everything from me plus this.
Okay, I like that. I like that. What else would you say? Can we add to that? Can you add to that?
That's pretty good.
That's pretty good. Well, how about this? So if I was going to talk about it in an interview, and someone asked me, what's inheritance? I would say, well, you know what? Inheritance is a methodology that we use, right, in object-oriented programming, right, to get all the things, classes from the class, methods, properties, copy everything from the superclass and pass it, right, into the child class, right? And that's what I want to do, everything. So my child class is a specialized version of my superclass or my parent class. Okay, that's what it is. A specialized version, just like you're saying. So he has hair, you don't. So it's a specialized version. He's not necessarily better. He's just more specialized than you are. Okay. So so what it means is that we can make subclasses that have more. It's usually the subclasses are fatter. They're bigger than their parent classes, right? And it allows us to further specialize in the subclass, make it more realistic, and match what we have in the real world closer than the superclass. All right, and we'll get to there in a second. Now let's go continue from there. All right, so what's a bad thing? Here, I'll get you a chance to talk. What's a bad thing? One bad thing that you would say about inheritance? Could you think about a bad thing?
It gets really complicated.
It's complicated if it's an error. Okay, what's a good word for that? It's almost like it has a dependency. It depends on all the dependencies. It collects the dependencies from its superclass, right? So if I have a bunch of stuff that I've programmed into my superclass, now it's in my child class, right? Or my the class that I'm the derived class. If I'm going to use base class, superclass, derived class is or child class, it all means the same thing. I want you to think about it in your head that it's a specialized version, but it inherits all the problems and the dependencies from the superclass. So, and I said this earlier, so please forgive me when I'm saying this. I'm not saying this to make anyone angry with what I'm going to say, but it's just for clarification. If the parent has cancer, so too does the child in this case. Okay, I want you to think of that. It means if it's sick, the child is sick too. If there's a problem with the parent, the child has a problem too. And if the parent is really, really fat, the child is fatter. I'm saying that in terms of how much code there is, right? I'm not saying this is in real life. I'm just talking about here in coding. But I want you to keep this in mind because we want to make lean superclasses, right? Lean superclasses. And also, inheritance may not be the only methodology we use when we build up our projects, right? It's just one aspect of object-oriented programming and design. So when we make our new assignment 4, which is out, we're going to be talking about something called abstract classes today, right? A little bit, and interfaces next day, okay? So here's what I want you to build. Now this is a solo assignment, which means you're not to work with anybody else. It's just you and you alone, all right? So you're not going to combine or pair up with anybody, right? I don't want you to copy from your neighbor or your friend or look online. This is all about you, right? And copying is a really bad thing, and I'm really kind of good at finding people who copy, right? And I'm not challenging you to copy. Hey, copy, and I'll find you. No, I'm not saying that. Please don't do that. I'm saying please don't, because you're going to need to know how to do this stuff on an exam. And if you don't know how to do it on your own, it's going to just come back and bite you later, right? It's also a good gauge for me so I can look at what you're able to do when I give you an assignment, because I haven't had you before, right? So here's what you're going to do. You're going to make a Planet abstract class. And I want you to think about an abstract class as a blueprint to the blueprint, right? An abstract class, the difference between an abstract class and a regular class is you can never instantiate an object of an abstract class. So I can't make a Planet, as an example, object, because Planet really doesn't mean anything, right? If you think about it from a business perspective, it's just like we talked about person. Person really doesn't mean anything. Person really should be an abstract class, right? It's an abstract concept in our head, just like animal is a real abstract class, right? But now I have some concrete classes. So abstract class and concrete classes. A concrete class is a class that I can instantiate from. So when you hear these two words, concrete and abstract, that's what they mean, right? So a concrete class, I can make an instance. And notice that I'm using the class diagram here, and I'm pointing to my parent class, which happens to be an abstract class. Notice how the Planet superclass, which is an abstract class, it's pretty big, right? It's got all kinds of stuff in it that I want you to build, right? And then I have these two subclasses, Giant Planet and Terrestrial Planet, right? Giant Planet will be things like Jupiter and Saturn, and Terrestrial Planet is like Mercury, Venus, and Earth, right? Right, so those are the two types. And I probably could have had another one, Dwarf Planet, which could have been another kind of planet, like a terrestrial planet, but much smaller, right? I have also this other thing here, this other symbol, right, which is this little dot here, which is really the interfaces. This talks about interfaces, and we're going to be talking about interfaces on Thursday, right? Interfaces are, I want you to think about them as contracts, right? It's almost like a way of accessing or building up our class, right? So I create interfaces as separate classes on their own. That's what they look like. And they have the signature of the methods, right, that I want to include in them, but there's no definition. The methods themselves are empty. So they just have a semicolon. So the name of the method, the signature, and that's it. And then what it does is when I implement the interface, right, then to implement it, I must define and further define the method inside of my class that's implementing the interface. Okay, so people are going to say, well, what the hell do I need that for, right? That's like I make an interface and then I define the method. It's like a method signature, and then I got to use it. Well, yeah, because in a real world environment, it kind of says to anyone who uses my class or who inherits from my class, like let's say if I make another class from Giant Planet, maybe I make two different kinds of giant planets. Well, what I can do is I can say, well, you need to have two interfaces here if I want to make another kind of giant planet. I need to have one that has moons and the other one that has rings. So you can notice that the has moons and has rings interfaces are being implemented. That's how we say them. How we talk about them into this giant planet class. So the giant planet class extends planet. This is review, right? The planet superclass, which is an abstract class in this case, and implements has moons and has rings. Notice that I'm not saying I has moons and I has rings, because I stands for interface, right? That's all it is. And that's the kind of an identification tool for us. So I has rings and I has moons and so on, okay? And notice here that there's two methods, has moons and has rings. And I have to put these methods in because I've made a contract with these two interfaces that I'm going to make these methods, I'm going to implement these methods inside my class. Same with my my terrestrial planet. I have has moons, the same interface for my giant planet, right? Because it could have a moon, but also it's habitable. It could be habitable. And there's only one habitable planet here in the solar system, as far as we know, which is Earth, right? So that is an example of the structures that I want you to build out, right? There's also the driver class, and the driver class is going to be called program. and it's going to be implementing or instantiating objects of type giant planet and terrestrial planet. In my case, for this assignment that's worth 10% of your final grade, I will not use a harness. All right, there's no harness for this one. I'm just going to get you to follow the instructions in the assignment. Okay. Also, notice that there is a method that we're going to implement together called wait for any key, which is actually going to wait. It's going to pull the console. So when you press the button, then it'll hide the console, right? Because right now what happens is you press Control F5 and then it'll kind of pause everything. I don't want you to press Control F5. I want you to start doing some advanced debugging. So I want you actually to debug, and I'm going to get you to use this wait for any key method that's going to be part of the program. Okay, so this is the structure. I've kind of given you a map of what I'm looking for, and then down in here, I'm giving you specific instructions, right? Now, the specific instructions that I like to kind of give you, and don't worry about the errors, they're just, my word doesn't understand what these are. But think about this. It's going to be broken down into functionality, program structure, internal documentation, which is comments, and version control, which is GitHub. Remember I told you I'd be doing GitHub? Every assignment, every test we do together, every lab, GitHub, okay? All right, so here's the first part. Part 1, abstract class planet must include the following properties and methods, and I tell you what to do. And it's worth 24 marks functionality-wise. That's almost half of the 68 marks that this thing is worth, 68 marks. Now this marks, when I'm saying marks, I mean slices of 10%. That's what I mean, right? Slices of 10%. 10% is your final, the weight of this assignment. So there's 68 points I'm going to be looking at for this assignment, right? For you to get perfect, let's say. So 50 of them are functionality, 8 marks are program structure, and so on. 24 of these functionality marks are going to be in this abstract class. 7 marks for making private instance variables, these ones. 7 marks for doing public properties, these ones. 6 marks for making a constructor method that takes this stuff, right? And 4 marks for functionality for this to override the toString method that's part of every class, which we'll talk about. Now, can you do this whole assignment right now? You don't know everything yet, right? But can you do it? Yes, you can start it. You can start by making the class structure, like up here. What's wrong with doing all this? I would recommend starting right away. This is due, by the way, Friday, July 28th, 2017 at midnight. That means 2 weeks from now at midnight. And we're going to talk about how that works. So it says week 11 because tonight, right now, from a lesson week, we're lesson week 9 officially. Okay. All right, so that's the first part. So part 1, that's how I do it. Everything I ask you to do, there's a mark associated to it, right? And then class giant planet. That's what I want you to kind of create. It's a subclass of the planet abstract class. The class will implement both the IHAS-moons and IHAS-rings interfaces, right? And it tells you stuff to do here. Each line that it tells you to do, as an example, has 2 marks, right, associated with it. Terrestrial planet is very similar. So, example, giant planet is worth 8 marks total when you create your giant planet class. And terrestrial planet is worth 7 marks, right? So you can see that 7 and 8 is 15. And 24 is 39 marks so far. And so if you just do those things, you can pass, right? But you can't really do them without doing the has-moons, has-rings, and habitable interfaces, which I talk about. Okay? Great. So you've done your classes, and now it comes down to your driver class. What's the driver class? It's the program class that comes with your file. And if you notice, it says in the program class, this is kind of like your test harness right here, right? Where I get you to instantiate objects of giant planet and terrestrial planet, and this method for wait for any key, which we're going to talk about. Okay? So that is worth, just if you do the program class, just the programming alone, 5 marks functionality. So now all your functionality is here. It's already, all your marks for functionality is here. And now you're into program structure. Program structure is worth 8 marks. It's not something to forget. It basically tells you that things have to be named a certain way, right? For example, you know, giant planet, your driver class will be named program. Please don't name it something else, right? People do this all the time. I give them instructions worth 1 mark, and they name it something else. They're like, but it's okay. No, it's not. I asked you to name it program, name it program. Trust me, it's like that in the real world. If you name it whatever you want, people get mad at you, right? So don't do that. You can get in trouble. Same thing with abstract, this abstract planet class named planet. Now, some people complain. They say, well, shouldn't it be called abstract planet? Yes, you could probably argue that it would be called abstract planet. I probably would accept it without a mark loss. But please just call it planet, right? giant planet, terrestrial planet, makes sense, and different interfaces with the names that I've asked you to. And then there's one part here, part F, that says, hey, all your member variables or class variables, instance variables, call them what you want, they all have to have this underscore, which is what I talked about in terms of our best practices for our class. Now, people in the coding house outside, they may disagree. They might say, no, don't do that. You know, they might have a different naming convention. In our naming convention, that's what I'm asking you to do, is with 1 mark. All right, internal documentation. Okay, so ensure you include a program header that indicates the author's name, the author's student number, the date last modified, your program description, a revision history. That should be in every file that you add into your file. And we're going to do that today. I'm going to show you how to do that when we comment. And that's just a comment header for each of your classes. Okay. Ensure your program uses contextual variable names. I don't want to see A's and B's and C's, or X's and Y's and Z's, unless you're talking about coordinates, X, Y, and Z, right? It has to be contextual. You have lots of room to make a whole, you know, like the names of your variables human readable, which is what I want. Okay, so documentation, 6 marks, right? Okay, and finally, GitHub. GitHub, to demonstrate GitHub best practices, you're going to put your code up on a repository, right? And you're going to share it with me. That's just putting it up for the first time. Your final version is only worth 2 marks, right? If you want to get full marks, the full 4 marks, you need to work with GitHub. And that means every time you make a change to your code, you make a commit, a new commit, another commit. And then keep doing that, keep pushing it up to GitHub. And I'm going to show you how to do that today. All right? So that's your 4 marks. Okay, that's it. Now, submitting your work. Remember, there is no physical file you're going to give me. I don't want you to transfer a file to me through email. I will reject it. All right? Please don't send me your assignment. I'm not going to take it. Everything is through eCentennial. All right? eCentennial, there's a Dropbox right now. If you actually go up online, you'll see it. The assignment details that I'm showing you right now are up on eCentennial. And this is where you're going to submit your work. All right? It's individual, just you. You're not going to share it with a partner or friend or someone from another class. It's just your work. You need to have a zip archive of your project files. Please do not give me a raw archive. I will not accept it. Okay, so zip archive only, which means you can download something like 7-zip for free, right? A link to your project files on GitHub, and I'll show you what that means, but I need these 2 things, right, for your submission. There's no report or anything like that, just these 2 things. And take a look at the rubric here, 50 marks for functionality. Okay, that's cool. So maybe all you did was this. You're like, I'm a coder. I don't care about documentation. I don't care about GitHub, right? Great, you're gonna lose 14 marks, 18 marks you're gonna lose if you don't do those things. I don't understand why it takes too long to me to, don't tell me about it takes too long. It's required, it's part of our coding style, right? And I've heard these things in the past, right? Where they say, I don't wanna do my internal documentation, I don't wanna add comments, I don't wanna add my version control, I just wanna code. Well, I'm sorry, there's no world that I live in that all you do is code, okay? You know, so maybe you're gonna find a coding house that accepts that. I don't, right? So I want you to think about the coding, the program structure that you're gonna have to take. It's worth, if you don't do this, you lose 18 marks. That means you can only do 50 out of 68, okay? Those are easy marks. These things here, 8, 6, and 4, that's for people who don't know how to code. If they just do this, right, as an example, they 14 marks out of 50, out of 68. That's on your way to passing, right? If you don't do this and you're excellent, you did 50 out of 50 on this, you don't get perfect on the assignment, right? And you wouldn't do perfect on the test either. So please don't forget this stuff. All right, this assignment is worth 10% of your final grade. Each day late, if it's due on the Friday, if you hand it in on the Saturday morning at 1 o'clock in the morning, Saturday morning at 2 o'clock in the morning, Saturday morning all day, it's worth 8 out of 80 now, right? If it's on Sunday, it's out of 60. If it's a Monday, it's out of 40, and I'm not going to accept it past Monday, right? So Monday, that would be the Monday after the 28th, which I think is the 31st, July 31st? Yeah, July 31st, right? That's the last day you can submit this thing, okay? I put a little disclaimer here for external code. I really don't want you to put any external code, but if you find some really funky special effect you want to use, and it's only worth 10% of your code, which I don't recommend, and if I approve it, notice the steps. You must get written approval by me, right? Then you can up to 10% of your code if you want to. If there's something that's in there, like a class that you want to add in that's special, that's going to make your code stand out or something, you need to let me know about it. And if I approve it, you can use it. Otherwise, if you have a question or if you're unsure, don't use it. Okay, that's the answer. All right. So Can you use my code? If I tell you you can use it, then the answer is yes. If I've shared something with you up on GitHub, then chances are you can use my stuff. Okay. If it's something if there's a pattern that I want you to use, it's okay, right? But if you're using your friend's code, if you go to their GitHub account and you take their stuff, guys, it's the easiest thing to find. And please, like I said in the earlier class, right? Moving around variable names, renaming them, and changing your methods around, right? Because you think that's going to fool me because your code has a different, slightly different structure than the other your buddies, right? It's not going to fool anybody, right? Definitely not me. Trust me, I know all the tricks. All right. It's been a while, but I know all the tricks. So think about this, right? I want you to think about how I'm going to put this thing together. You get 2 weeks. My recommendation is you start today. All right. I know people say they've got other things going on. You've got other things that you're going to be doing. Please don't wait. Please start today. Start putting this. This is a very simple assignment. It's worth 10% of your final grade. And it really just gets you to practice with advanced classes, inheritance, and polymorphism. Okay. That's really what it does. That's what this whole thing is about. Okay. How about bonus stuff? Is there an opportunity for bonus? And I kind of talked about this. What if you added, this is the base stuff that I want you to do. What if you added in a dwarf planet class? I didn't ask for that. Could you? Am I going to stop you? Am I going to come down on you for adding extra stuff? No, I'm not going to come down on you. In fact, if you add any extra bonus stuff, I'll take it into account, but you got to let me know. You got to say in your submission, hey, by the way, I added a bonus dwarf planet class and it does this, or I added an asteroid class, right? Something like that. That has nothing to do with, the other two classes. And it does these are different things that it does. Take this abstraction example further, right? I don't mind when you do extra work. I think it's good. I think it's good practice for you guys, and it prepares you for the exams. I'm not going to punish you for you doing extra good work. Okay. Any questions around the assignment? This assignment number 4 again is due week 11, so 2 weeks from today. Well, actually 2 weeks this Friday, right on July the 28th at midnight. All right. Let's get to it. So this is what I do every time we have an assignment or some kind of lab. I'll do the same thing on Thursday for the lab that I'm going to get you to do. It looks big, but actually it's an illusion. It's not that big, right? This makes it look big, but it's not that difficult. If you actually follow the instructions and put this together on your own, you'll be fine, right? Do you have everything you need to do? But you won't have it until probably Thursday. If not next week, it's okay. You can still start on it, and that's okay. We can do it together. So by the time next week rolls around, you've got most of your assignment done, and you can hand it in, right? And the other thing I recommend for assignments, and I kind of didn't talk about that in the first class, is you can submit as many times as you want up on eCentennial, right? And I'm not going to take away from that. I'm going to only take the latest one that you submit. So there's nothing wrong with submitting often, right? Submit early, submit often is my rule. And the reason for that is, what if you submitted something and it's before the due date, as an example, and then something happened to you and you can't finish it or whatever, right? Sometimes it's better just to submit something that's not 100% complete, but it's going to be better than losing 20%, right? Remember, 20% of 10% is 2 marks, 2% after final grade, right? That means every day that you delay to hand it in, Saturday, that now you can only you've just lost 2%. So out of 100%, you can only get 98. Right? And then on Sunday, now it's 96. And then on Monday, now it's 94. You just lost, a bunch of marks from your final grade. Why would you do that? That's crazy, right? Hand it in early, guys, right? Don't wait till last minute. I know what's going to happen. Some people are going to wait until the 26th, right? Or the 27th to start their assignment. This is not that kind of assignment. Please don't do that. There's lots of little parts in this thing and things that I'm asking for. You'll just shoot yourself in the foot to do this. This is a bad thing, right? And also, I'm going to be available for office hours on Tuesdays and Thursdays. I'm here on Tuesday from about 1 o'clock, right? So please, you can come see me in A230 downstairs from 1 o'clock. I'm also available after class on Tuesdays. On Thursdays as well, I'm available early, but you need to book with me. Don't just show up for classes. Send me a note saying, hey, Tom, can I meet with you at 9 o'clock on Thursday morning? And then if no one else has booked it, or if I'm available, I'll say yes, and we can meet for half an hour about your problem, right? And then the same thing with after class on Thursday. I'll be available for you guys after class on Thursday. So those 2 classes, please don't try and meet with me on the Friday, because I'm not going to be available for you. Don't send me email on Friday afternoon saying my dog ate my computer, somehow my GitHub is broken, I can't submit my assignment. Can I get an extension? The answer is going to be hell no, right? There's no extensions. Not because I'm a bad guy, but because you guys have 2 weeks, right? Come on. You have 2 weeks to get your stuff together. Start early. Commit and submit often, all right? Make sure your GitHub is not just your last version, because you're going to lose 2 marks immediately from your final your mark for your assignment, right? You need to commit regularly. All right, any questions? Any other questions around assignment number 4? I kind of added some other stuff there. All right, let's get to it. So last week we talked about, or the week we were gone, that was week 8, and that was before our break. We talked about, the notion of inheritance, and I said I wanted you to have private instance variables, right, and public properties, and I wanted to use the public properties even inside the class itself, which is the method that I'm asking you to do this as a programming methodology, right? Why? Because it allows us more control. But let's suppose this private data structure that you're creating, this instance variable in a superclass. Can I access the private instance variable in my child class? Can I do that? No is the answer. And should I? And the answer is no, right? But sometimes, as a workaround and to solve problems, we may need to access the data, the private instance variables from my superclass. I may need to access them in my child class. And for that, we can rename the private we can move them from private to protected, right? Protected not only allows us to make them private to the class, but also it allows access to child classes that derive from my superclass, right? So it actually opens up some doors. It makes it less protected. Even though it says protected, it's not the same protection level as private. Private, that access level, is the smallest access level. Protected is a little bit of a larger access level. And public, of course, is the largest access level. You can access it from, anyone can access it from anywhere, right? So protected is okay, but like it says down here, it says it should be used sparingly, right? Why? Because we don't want to do it. It's not great form, but it solves some problems sometimes. And sometimes you may be working with an API, application programming interface, that someone else wrote, and you know what? The only way they've written it in such a way where it needs to be protected and you need to access it directly. I don't recommend that. Okay. However, this is how it looks. So here's an example. We use let's say the employee class, and again, if you can't see it, please see the slides online. The employee class uses protected, and now here's something. In the book example, they have private and protected inside the same thing here. And what's wrong with empnum for me? What's wrong? What's missing here in empnum? Underscore, right? That's our best practice, that or our convention, if you will, that I'm asking you to do. How about this? Here's a protected and emp salary. How about empnum and emp salary? Are these good names for variables for me? Right? No, I don't want you to put empnum and emp salary, X's and Y's and A's and B's and I's and J's. I don't care about those things. Put employee number, right? Nothing's wrong with that. You have lots of room, right? And it's okay to do that. These shortcuts and everything else make the code less human readable and makes us guess. Yes, can we guess its employee number? Sure. Is it always going to be the case? No. It'll be ambiguous sometimes, and we may be confused. So please don't. Make it so it is more human readable. So here's our public property. Notice it uses this employee number, but it's inside the employee superclass. But when I go back to I know this is difficult to see. If I can zoom in here, I will. And if you look at the commission employee child class, right? Take a look now, right? Here's empsal, right? Emp salary, employee salary, is actually the protected. Because it's protected, I have access to it directly, right? Now this is okay in this particular instance because it's inside of a commission rate property, right? So I'm actually creating a new commission rate property, and this is where I'm saying it solves some problems because I'm accessing the employee salary at the same time that I'm setting the commission rate value. And that's why accessor methods, getter and setter, is way better than accessing the data itself, because I can do more stuff in there like I'm doing here. Okay? So this is okay, not recommended. I may have done this a little differently. For example, if I had an employee salary property, I may want to use that instead. Okay. Anyone clear? So protected, is it going to be on your exam? If I ask you what protected means compared to private, yes. If I talk about it and if I spend a few minutes on it, chances are I want to talk about what's the difference between private and protected. Protected is an access level that's a little bit more open than private. Private's a little bit more closed than protected. It gives you more of a protection level, right? It's only for the class itself, not for its child classes. Protected is for the class itself, the superclass, and all of its derived classes, okay? Okay, and here's a further example of that using employee salary directly. I don't recommend. Okay, so let's skip through this. Now, there's going to be some parts of this PowerPoint presentation that I'm going to skip through, and it's because it may not pertain to us and or I don't think it's important. But it's not that it doesn't exist. All right, polymorphism. Okay, what is polymorphism? If I was going to ask you this in and tell me in your own words what it means, let's talk about the Greek. Who knows what poly means in Greek? Anybody? Multiple or many. Yeah, Greek actually is where this comes from. Polymorphy, right? I'm teaching you Greek too. At the same time, I'm a Greek professor, so I got to teach you, the Greek stuff too. So you come away with a little bit of Greek, right? So poly means many, right? Morphe or morphes, right, is forms or shapes. So many forms or many shapes, right? So that's how a lot of scientific words come from the Greek and Latin, right? And this is where it comes from. So polymorphism means many shapes or many forms. It allows us to take an existing method, right, as an example, this idea of polymorphism, and modify it to further specialize it for a particular class. So an example, I might have a talks method or is talking method, right? And it might be this, in one class, in the person class, it might be, it might do something, but maybe in the student class, it does something totally different. And we can modify the original method by using the override keyword, okay? So here's an example of what that looks like from a syntax perspective. Let's go in there. Notice how in my credits accessor method, here's my property, right? I use the virtual keyword. This is the setup. I have to use the virtual keyword to tell C# that, hey, credits is a property that I may override. I don't have to, but I can if I want, right? Okay, so public virtual is the way it looks. So I can override the credits method, right? The credits property, right? Doesn't matter whether it's a property or a method. When I use virtual, I have the option to override. And that's the first step. The second step is actually overriding, which is done here. I use the override keyword to override the public property. Now, what's the difference between this one and the other one? Well, you notice that this one has a getter and a setter, and this one only has a setter. Now, one of the students asked me this in the earlier section, so do I have access to both versions? And the answer is no. Once you override your property or method, then you override. It overwrites everything. So this is what's available to the scholarship student compared to this being available to the regular student, right? This is the regular student up here. This is the student superclass, right? Make sense? So the override keyword. And somebody will go, why would I ever want to do that? Well, because I want to maybe further specialize something in the method to make it even tighter. Take away some code probably. How about that? Maybe the initial method is pretty fat, right? And I want to further specialize to cut the code down. And so for that particular class, it's leaner, or maybe it only serves the purpose that I need for that particular class. And it makes it so that the classes are less dependent on their superclasses than it was before. And this is something fairly new over the last 10 years or so. Okay, so here's an example of that. Here's your paying student. Paying student is a regular student, right? Here's your paying student, and here's your free student. I can assign credits to both, but when I read, I can only read from, because there's no reading from my free student. I'll get an error if I try and read from it. Okay. How about the keyword base? We used that last time as well. Base was a keyword we used, and base allows us to access a method that exists in the superclass. Now, we did that from our super constructor. Our super constructor, when we made our constructor, we accessed the super constructors by using base. We said base, and in base, what we're doing is we're actually calling the super constructor. Why? Because if I make a custom super constructor that does not include, or a constructor that doesn't include or includes other parameters other than the base constructor, the empty constructor, then I must use the base keyword. And you saw that last time when we did that together. Okay? So that's what base does. However, you can also do this for other methods. So if I want to access another method that's in the superclass, I can do that by using the base keyword. Now, just because I should do it, or I could do it, should I do it, that's a totally different thing. Just because you have a gun at home doesn't mean you have to shoot your neighbor, right? You can shoot your neighbor, but you shouldn't shoot your neighbor, okay? Don't shoot anybody, all right? Because that's bad. Just because you can doesn't mean you should, right? And a lot of programming languages, I give you a lot of power, things to do that you can do, but you have to choose to do the right things, right? Great power comes great responsibility, like Spider-Man. By the way, anyone seen Spider-Man? Right? Yeah. Is it a good movie? You think it's a good movie? Yeah. Is it a good Spider-Man movie though? Right?
Yes.
No, I don't think it's a good Spider movie because he's got a super suit, man. Spider-Man never had a super suit. Okay, I gotta go. Spider-Man was he was a poor guy, man. He was a poor guy. A new class of Spider-Man. Yeah, there we go. So anyway, so we got this. Here's an example of the base class, just to go back to that. Am I going to get you to do this kind of stuff where I go base get greetings? Get greetings is part of the superclass. Chances are not. I mean, if I wouldn't get you to do this unless, by the way, I'm calling get greetings from within my new public greetings class. I mean, I could do this, but I don't think I would. All right, but could you do it? And would I ask you about it on an exam? I could ask you a question about it. Okay. All right, the idea that when we think about a class, a derived class, as having an is-a relationship with its superclass or its parent class. And I want you to think about that. When I think about person as a superclass and the child class being student, student really is a person, that idea. And this is just review from what we talked about last time. So what it does is actually converts from one class to the other. So if I kind of create a new object of type student, I can check to see if it's a person, and it is, right? Student is a specialized version of a person, but it's still a person. Okay, that's what this is saying. And sometimes we need to do that. Okay, and I'm not going to go into this too much. And then the whole idea of the object super duper duper class. Okay, and I want to talk about that in a second. I'm going to go to code because you guys are getting bored, and some of you are going to fall asleep because of the PowerPoint presentation, which I really hate. So think about this. Think about that whenever you create a new class, don't you see that there's extra stuff that you can do with it? Because it's inheriting. Anytime you create a class, it actually inherits. Every class we create inherits from the object, capital O, superclass that exists in C#. And the same thing goes with Java and other languages, right? There's always a super duper duper class, the class of all classes. That's what object is, right? So the object superclass has a bunch of methods that are built in, right? And we're going to talk about them. So let's get some coding done, all right? Let's start this coding stuff off. So let's start this off, right? So let's go to Visual Studio. I'll bring up Visual Studio 2015. Remember, what I'm going to talk about today is a little bit more of inheritance because I want you to see it again yet another time, right? And I recommend, again, please start your assignment number 4, right? You wait, it's going to take too long. Okay, so here I am in Visual Studio. Please do this with me. This is a we do together, right, exercise. I want to click on New. And we've done this last time, and you've done it many times before. I'm going to make this new project. I'm going to call it COMP123, Summer 2017, Lesson 9B. You guys are the B class, right? The second class, not necessarily a bad class. Notice that over here, and you guys forgot to do this, some of you last week, click on this Create New Git Repository. You may see it as Add to Source Control. Please check this. If you don't check this, you will not be able to add it to Git, right? Then click OK. One of the things that was asked, by the way, for assignment number 4 was, how do I name assignment number 4? Do I just name it assignment number 4? I just want you to name it assignment number 4 dash and your student ID, okay? That's what I want when you hand it in. All right, take a look at this. So I've got this, my program class. Here's my program class. And I'm going to do this a little bit differently than I did this morning. In my program class, what I want to do is I want to start my commenting, okay? So here's my program class. I want to start my commenting, and I want to use this comment style, right? I'm going to say my name is me. You can put your name. And the date, which is today's date. And a description, right? This is demo for lesson 9, right? And then version, right, is 0.1. I'm going to say created the program class, right? Because that's all I've just done right now by making my new project, right? Hey, cool. I've got my first little thing here. I'm going to save. I'm going to go to my Solution Explorer or my Team Explorer. This is right here, right? It'll come up. It'll pop up. If you don't see this, you'll see the Solution Explorer. If you've pinned it on the bottom, there's a tab you can hit, Team. If you don't see it, you can go to View, Team Explorer. All right, do that. All right, cool. And if you notice, I'm going to do my first commit. So I'm going to go to Home, right, in my Team Explorer, hit Changes. You can see that I've got one thing I've changed, which is my program.cs file. And I'm going to say modified program.cs, right? I'm going to commit all. There we go. I've got a local commit, right? It's my local commit right now. And I want to push this up to GitHub. So I'm going to click on Home. I'm going to go to Sync, right? And notice that there is this couple of options. One of them is Visual Studio Team Services. No, I'm not going to use that one. I'm not going to publish remotely by hand. No, I'm going to use this one, publish to GitHub. And the way to do that, to get that option, is to go to Tools, like I showed you before, Extensions and Updates. And if you look online, and if I search for Git, you can see that there is a GitHub extension for Visual Studio. That's the one I want right here. And I will download that if you haven't done it already. Okay, please make sure you have this, because you won't look like this if you didn't, right? And I'm going to click Publish to GitHub. Now, if you've never done this before, it's going to ask you to put some credentials inside, your email account and your password and so on. It'll ask you for the first time, and then it'll remember after that. Okay, cool. Notice that I have many accounts here. I only care about this one right now. So you got to choose the right account if you have multiple accounts like me. But the ideal thing is to notice that the GitHub repository is the right name. So COMP123 S2017. It took the name of my project and is using that as my Git repository. And I'm going to click Publish. That's all you need to do. It's going to go up to GitHub and publish my GitHub repository online. Where is this? Where am I looking here? Let's go and find it here. Here's Centennial College. And if I refresh, you can see now that I have 9B. Here it is, 9B, right? 13 seconds ago. Yay. Right? All right, cool. 13 seconds ago, my 9B. Hey, take a look what else I got up here. I got no description, right? And I've got no Readme file. Okay, let's add a description. This is something you remember every week I'm going to be talking about new things about GitHub, right? Because you need to know how to use GitHub. You need to ramp up. If you don't have a GitHub account by now, please sign up. Okay, this is your second chance to do it, right? You need to do it as soon as possible because your assignment number 4 requires it. And it must be your own GitHub account. Please don't give me your friend's GitHub account. That will be very suspicious, right? Okay, so I've got my GitHub account. What am I asking for when I ask you for my GitHub account? I don't mean this. This is just my generic GitHub account, right? I mean, with my repo, I want this. I want you to give me this link for your repo. If this was assignment 4, this was the link you gave me. If you gave me just this is your whole account. I don't care about your account. I want your repo, right? That's what I want for your up on GitHub. When you give it to me online on eCentennial, this is what I want. Okay, cool. So I've got my GitHub account. I want to add a description. I'm going to add it here. I'm going to say a demo for lesson 9, right? That's what my description is going to be. Notice it came in there in my description. You can add other topics in here as well if you like to make it more descriptive. Here's something I want to do. I want to add a README file. Okay, here's my README file. But this is an actual file. I'm going to modify my Git repository and add something new. What this is going to do is it's going to push my commits one forward. So I'm going to have more commits online than I do locally. And that's a problem, right? But I'm going to fix it. So I'm going to add a README file. And when I click Add README, it's adding this new file called readme.md, right? Now, it has a different structure. And notice there's a hashtag here. This hashtag is like an H1 tag if you're an HTML person. It makes it so that this is a very large heading, right? And then a comment demo for lesson 9. You can actually put your entire documentation in here. If you're making a new application, you'll see a lot of documentation in here about how to use your application, how to make your how to launch your application, how to do different things with your application. A whole help can be in here if you wanted to. Now, down in here, notice there's a commit. I can add a custom commit, or I can accept the default commit, which is create readme.md, and click commit new file. When I do that, it adds a new file to my repository. Notice now that I have this readme.md file and a little comment that comes up here, right? In days past, when I was first programming, I had to give a physical document to my manager. And this is, kind of taking the place of that. You can actually give them access to your GitHub. You have everything that's in here. It documents your application, what it's doing, and so on. What's the purpose of your application? All that stuff you can put up here if you want to. And that's what the README file is. Now, that's great, but we have 4 commits online. And if I looked back on Visual Studio for a second, so here's Visual Studio. And if I go to Home, and if I go to Sync, and if I click on this little action over here, take a look, right? I actually have access to my command prompt. I want you to show you here that if I go git status, right? It says I'm on branch master, right? But if I go git log, it shows me that I have 3 commits. I have this one from Microsoft, this one from Microsoft, and this one from me. But that's locally, right? I did git log here, right? But if I look online, right? So if I look online, here's online. Notice I have 4 commits, right? I have my Microsoft ones, these 2, mine, and this one that I just committed online. Guess what? I'm out of sync, right? And that's a problem. If you try and sync up your Visual Studio right now, if I add anything else to my Visual Studio right now, it'll mess up. So we want to pull. If I pull, I go up on GitHub and drag in that commit. And if I look at my command prompt now, just to show you the difference, so I'm going to just clear this, right? And if I go git log, you don't have to remember these commands, by the way. Notice I have 4 of them now, right? I'm in sync again. I have 4 locally, and I have 4 remotely, right? Will I ask you about this in the exam? No. This is not for this class. I'm just showing you as for enrichment. But for you guys, you need to know why we're using GitHub. We're using GitHub for 3 reasons: backup, collaboration, right, and version control. Those are the 3 reasons, right? That will be on your exam. That question is going to be on your exam. Take note. I'm going to ask it, right? Okay, so we did it. We added stuff to GitHub. I went really slow again. You've seen GitHub for the 2nd time. And I'm doing that because I want you to understand how to do this, how to use GitHub. This is the stuff that you can use. So if I'm too fast for you today, go up on GitHub, take a look, and follow me here. All right? All right, next. What I want to do here is I want to start creating my example. And today I'm going to make a human and superhuman. All right? Because I want to make the superpowered human. And I want to make human, think about human now. Is human something that really means anything in the context of not really. I mean, it's kind of a generic idea of what a human is. But just like you said earlier, it's like a person. It's got 2 arms and 2 legs, but it doesn't really mean anything in our business context. If I'm making a superhero game, right, I want superheroes, right? There's 2 types. There's a hero and a villain, right? But to get to that abstraction level, I need some kind of basic class that holds some stuff. For now, we're going to call this class human. And I'm going to create this by using the class diagram. So I'm going to go right to the solution structure, right-click. I'm going to go add, and I'm going to go new. Oops, say that again. The project I meant. I'll be okay. Add, new item. And I'm going to click on, when it comes up in this little add new item dialog box on the right, I'm going to click on diagram, right? And it's going to come up with a class diagram. If you don't see class diagram, it's because your Visual Studio version is not the same as mine. And that's the reason why. If you're using Visual Studio 2017, I think some people said that it's not included, right? If you didn't get the enterprise level version. All right, if you go with class diagram, I'm just going to leave it as class diagram 1 and click on add. What this does is it gives me this blank screen. So I want to add a new class diagram. All right, so I'm going to so my new class, right-click, add class. And this class is going to be called human with a capital H. Here we go. Here's our human class. Now, I could have added an abstract class, but I wanted to show you how to make an abstract class from scratch, right? Notice this is the diagram of my class. Up here, I have the ability for me to see a full signature, which I'm going to click on. Right, so here's my full signature, and also full length. which I'm going to click on, this thing here. Now, nothing is in there right now. It's empty. If I double click, it takes me to my code, right? And I have my human class. Now, it's just a scaffold for my class. I'm going to comment. One, well, I already have this. So I'm going to grab these comments from here, right, to make it nice and quick. Go to my human, right, and paste them in and modify my description for the class is, you know, this is the human abstract class, or abstract human class, abstract human class, right? That's what it is, right? Version 0.1 is I created the abstract human class. Right, that's what I did. Right, that's version 0.1. And I'm also going to add some comments over here, right? So triple forward slash for the comments. This is the abstract human class. You can see where I'm going with this, right? Same thing we did last week. So I did this. I got some comments in here. I'm going to save. And now, all I want for my abstract human class is some structure at the beginning. I recommend, like I talked about last time, from a commenting perspective, I recommend put all your comment headers in ahead of time. So example would be public properties, right? Or fields. I actually did this different in the earlier class. Here are my, what else? My private instance, sorry, private instance. See, I'm all getting confused. Private instance variables, what these are, variables. And this is public properties, that'll be okay. Right, public properties. And then I have some constructors. I'll probably organize it like this. Here's my constructors. And I probably usually put a line like this, right? You don't have to. And down here, I might have some public methods, right? I might also have some private methods. I usually put them private before public. So I kind of structure how I'm going to do all my classes like this. Now, here's a trick for you to know. Sometimes, and I know some of my colleagues, when they program, take this, copy it, and put it into a text file, and then they never touch this again. Copy, paste, done, right? Or create a template where they launch. They create a template class that they kind of create, and then they never have to do this again, all right? But for you guys, it's okay if you kind of comment it by hand. Well, so what is this doing? It's just organizing myself. That's all I'm doing here, right? Is it required? For your comments, I recommend it. But what I'm looking for in your comments is your header for your assignment and where that the code is human readable. So the variable names aren't messed up, that they're not like shortened or something. All right, so my private instance variables. I want to create a string, right, as an example, and it's got to be private. So here's my private string. I want to say the name of the superhero should be private, right? This is the data that I'm holding together for my superhero eventually, right? But for now, my human has a name, all right? My public property, okay, here's my public property. Again, I'm going to use the prop short version, right? It's going to be a string. It's going to be name, capital N, right? And I have the opportunity to set up some getters and setters, which I'm going to do, right? Here's my getters and setters. And in my getter, okay, it's got a problem, right? What is the problem with my getter? Anybody? I'm talking a lot, and you guys aren't talking enough. Return, right? I need to return. My getter returns something, and my setter assigns something, right? So I'm going to return. I need a return keyword here for my getter. My return is going to return this _ name. Do I have to use this keyword? No, I don't have to, right? But I'm using it anyway to be explicit. I'm explicitly telling you. If I don't use it, it's implicitly there. It's implied that it's this, right? But I'm making it so it's explicit. Okay, and I'm going to say something like this. This _ name is equal to the keyword value. When I assign something to the name, it's going to be stored inside the name private instance variable. Okay, that's what's happening here. So that's the only time when you can directly access your instance variables inside your properties. Okay, that's what I recommend. Constructors. I want to create a custom constructor, right? So I want to say public, and the name of my constructor is human, and it's going to take two variables, or one variable, sorry. It's going to be a string. Make it quick. Name, and inside this, I'm going to say this.name is equal to name. Okay, so here's three names being used here, and people said to me, well, I don't understand. There's an _ name, there's a name, and there's a name. Isn't that bad? And the answer is no, right? Capital name N is property. Lowercase n is local variable that comes in from your constructor. And then underscore name N, right, is the private instance variable, right? And that's why I've done it this way. Okay, cool. We can also further comment my constructor, right? Because I want to do that. I want to use a triple forward slash for that. I'm going to say this is the main constructor. That's what we want to do it. That's not the default. The main constructor for the human class, what it does, it takes one parameter. I want to give it two parameter, and that is name, which is type string. Okay, so that's my little summary there. I've added this in there, and I'm almost done. And you know what? For now, I don't think I want to add in any private methods or public methods. I want to leave it like this. I would say all it does is my human has a name, okay? And it's an abstract class, which I didn't put in here. Where does the abstract keyword go? Should it go before public, before class, before human? Where should I put it? Anybody have an idea? I'm going to ask someone over there now. Okay, where should my abstract? Right there. What's your name? Yeah, you. David? David, where should my abstract keyword go? Should it go before a public, before a class, before the name of my class? Where should it go? What do you think? Abstract. I'm going to make it this. Remember, I talked about this is a different kind of class, abstract class. An abstract class cannot be, I cannot make an instance of the abstract class. I'm only using it as a blueprint for other classes, right? So where do you think the abstract keyword should go? Take a guess. It's one of three possibilities. Actually, there's maybe four possibilities, but so before the public, before the class, before the human, or after the human? Where should it go? Where should it go? Before the human. Actually, it goes before the class. So I go public, abstract, right, class, human. All right? That's the proper way. Public, abstract, class, human. Right? And what this does is it earmarks the human class as you cannot create an instance, an object of type human. You cannot. And this is because we're going to use this as a blueprint for other classes that we're going to inherit from, or inherit from this class. All right? All right, so cool. We've made our human. What should we do next? I want to make a superhuman. All right? Should we continue? Should we? We can. We have a gun. We can kill it. We can shoot our neighbor, but should we? Right? The answer is no. We shouldn't do it. We should actually put it up on GitHub now, right? This is, we just added a new class. Let's put it up on GitHub. Let's make a commit, right? So we're going to go to our team, right? And we're going to go to home, and we're going to go to changes. And here we go. We made one change. We added the class diagram, and we added this human. We're just going to say added a human abstract class, right? That's what we did. We could commit all. We can ask us to save. I'm going to press yes. And I've made my local commit. Now I'm going to put it up to GitHub. I'm going to go home. I'm going to go sync, and I'm going to go push. Now, someone asked me earlier, wow, that's a lot of things to do. Every time we add things to commits to GitHub, it takes so long. Oh my God, stop being a whiner. That's what I say, right? This is required, guys. This is like your, it's the next few extra steps, but it protects you. It kind of really talks about your coding style, and it also shows your development, how you're developing your application, right? And I'm sorry about this. It does take a little extra, just like test-driven development takes extra time. When Professor Narendra was showing that, it takes a little bit more time. But what it does is it adds structure, and it makes you a better programmer. Okay? So let's check and see what happens. So I made another commit online, and if I refresh, you can see now that I have 5 commits. Here they are. So here's my Microsoft stuff. I modified the program. I made a Readme file online here, and then I added my human abstract class, right? Notice that every time I add something new or modify something, I want to do a commit, all right? That's the volume that I want you to use, okay? All right, cool. So let's go back. So let's get back to that class here. So we've done this because I want to take a break soon. And now what I want to do is I want to make a superhuman class that is going to derive from the human class. All right, so I'm going to go back into my class diagram, right-click, and I'm going to go Add, New Class. Now notice I can call this superhuman, and I'm going to use capital S, capital H, right? There we go. Here's my superhuman class. There's no connection right now, right? And by the way, if you notice here, if I click on Superhuman and I extend it, I want to see the whole, if I want to see everything, right? So here's my entire signature. There's my entire signature right here. You can see that I can modify what my class diagram looks like, right? But here's my Superhuman class. What I want to do is I want to inherit. Oh wait, what do I need to do first? I got my new class, and it's another file. What's the first thing you should do? Comments, right? I'm showing you what to do to get marks on your assignment. I know you're going to freak out here, but I'm going to copy this again. I'm going to go back to my Superhuman. Just before the namespace, I'm going to go up here and paste, and then demo, instead of demo for lesson 9, this is going to be this is the Superhuman class that extends the human abstract class. So it does, right? And 01 is created the Superhuman class. By the way, we're going to see that this is going to be something we're going to need. Okay, cool. This is our header. We have this in front of every class at the top. Here, we're going to add in our Superhuman. This is the Superhuman class. Right? And again, you can put some more details in here if you want. I'm just skipping because I want to move on. Okay, in our Superhuman class, I want to have the same sections, right? So I definitely want to have my private instance variables, my public properties, my constructors, my private methods, my public methods. Right? These are all things I'm going to have in my classes. All my classes are going to have this stuff, probably, right? So organize yourself. Don't make it random, right? Otherwise, it's going to really look ugly. And if I read your code and you read my code, if we have all the same coding style, we have a language. We've developed a language in ourselves to talk about how we code, right? So this is what I want you to do. So, okay, so our private instance variables. Okay, so let's think about this. Oh, man, I have a problem. I want my Superhuman to have a list of powers. Is there a power data type? Uh-oh. So that's a dependency, yeah? I mean, I need a power data type to get a list of powers. So I kind of need that. I mean, I can do it other ways, but it's kind of the way I'm thinking from a business perspective. I'm thinking about how do I translate my business requirements, a list of powers for my Superhuman, right? Which is different than my human. Okay, that's one. And I want to extend the human superclass too, right? So here's my Superhuman. So I got to do this. My extends is what do I use? Colon. That means extends. Whenever you see the colon, means extends, which is human. Right? There's my human. I got to do it, but I got a problem. It says, hey, you got a problem because, it's telling you I don't understand how to, formally do anything with name, this parameter you've defined in the human. I don't know how to do anything with it because I have a custom constructor. I need to add in another one. So here's my custom constructor. So I'm going to say public, right? Superhuman. Do this first. And I'm going to take in a string for now, a name for the Superhuman. And I'm going to pass into the base superclass, I'm going to pass in the name. So that's required. That satisfies my requirements. Okay? Otherwise, I can't extend. So far, the Superhuman is exactly like a human, right? And you know what? This is a great place to do a commit because I know I need to add a power. I need to have this power data type. And that's a totally different thing, right? So before I build up my Superhuman class, I know I have requirements. I know I have dependencies in my head, right? And I'm going to use composition here to create my list. That's a different methodology than inheritance. Composition, I'm using a class. Inheritance, I'm inheriting everything from another class, right? So I'm using composition, which means this is a great place for a commit. So I'm going to go back to my Solution Explorer, and I'm going to go to my team, and I'm going to go to home, and I'm going to go to changes. And notice that I added my Superhuman class. I'm going to say that. I'm going to added Superhuman class. And commit all. Yes. And I'm not going to do a push yet. Okay? I can do more than one commit and push all the commits at the same time, right? It's not a bad thing to do either, because you imagine you're working and you want to do some commits locally, and then you go to the washroom. That's a good time to push to GitHub. Why? Because your computer could die, right? But by the time you get back, anything can happen. The building can burn, right? So, I mean, not to say that the building's going to burn, guys, but I'm saying, anything can happen. And you want to protect yourself. So that's why you do this kind of stuff. Okay, cool. So I've got my my superhuman class. Let's take a look at my class diagram here. I got an arrow that goes from my superhuman class, right? It goes from my superhuman class to my human abstract class, abstract superclass, right? So my superhuman class is really a human right now. There's nothing special about it, right? I need to specialize, but I need a custom data type, right? Like I talked about, this idea of a power, right? So what is a power? Let's go in there. So I'm going to add a new class, right? And we'll call it the power. Why wouldn't I call it powers? How come I wouldn't call it powers? It's a naming thing, right? But well, how come? Why is that not a good name for my my power class? Why wouldn't I call it powers? Because it's plural. Powers implies more than one. Power is one. I'm making one data type, like string, integer, and so on. It should if in your mind, you think about when you're translating business requirements, into code, you want to think about it. It should translate one-to-one as much as possible. Sometimes it's not possible, but we want to try and keep it as clean as we can. All right, so power. So power is the name of my class, right? And I'm going to click OK. And right now, there is no relation. See that there's no relation, and there's not going to be, right? I'm going to double click on my power class. And in my power class, oh man, what am I missing? I'm missing this, right? See what I'm doing to get all my marks for my assignment? Yeah. I know my professor wants me to comment like this. So I'm just going to do some silly comments on every one of my my files, right? Because that's what professor asked for. Oh man, why should we do this? It's a waste of time. I don't want to do it. Okay, so you can lose your marks, 6 marks, right, for not doing this. This is so easy, right? All right, so we want to create the power class. This is what this is. Created the power class, right? This is what it is. This is version 1. Here's my power class. What is this thing that I'm making, right? So I'm going to say something like // this is the power class, which will be used as a data type. Okay, cool. So I got my. So what do I want to have in here? Well, I want to definitely have some properties. Let's add these in. So I'm going to have some public properties. I don't really need to have private instance variables in this case, and we'll talk about why later. I can if I want, but I'm not going to. And maybe some constructors. I don't think I'm going to have too much of anything else in here. But for now, this is what I need, these 2 things. So my public properties, let's think about what I need for my public properties. A string, which I'm going to call name. So the name of my power. What's the name of my power? Example, teleportation. That would be the name of your power, right? And maybe another property, an integer, which we're going to call rank. So the power rank, how strong the power is out of 100, kind of thing. Is it a 1, really weak power, or really strong teleportation power? The guy can teleport across the galaxy. I don't know, right? So, this is the 2 properties. Right now, I'm not having a constructor, and there's a reason for this, but we probably could add one in too. So yeah, great. I've added my new power. Oh man, I added a new power. Great place to do a commit. Home. Go to changes. Notice I added a new power in there. I'll say added power class. Commit. Save everything. I committed. I got 2 commits now. Cool. Now that I have the power class, right, can I not create my list? Can I not instantiate my list, an object of that's a list object, right? Remember in my superhuman, I said I want to create a list. What type of object is a list? Is it a value type or a reference type? Which one is it? How about an array? Is it a value type or a reference type? How about a class? Is it a value type or a reference type? What do I mean by that, right? In other words, if I have an integer or a string, typically we call it a value type. We actually, when I assign something to the string, or if I pass something from the string, I'm passing its value. However, if I pass something from an array, the array, not an element of the array, right? I'm passing it a reference to the array, a pointer that's pointing at where the array lies or in memory, right? An array is a collection of a type, as a collection of the same data type, right? all the memory locations all in a row, if you think about them, a bunch of memory locations, right? People hate arrays because students hate arrays because they're confusing. But really, they're just a collection. It's almost like a matrix, right? A matrix of data. That's all it is. Well, the same thing goes with lists. List is a reference type. So if list is a reference type, can we access it in a property? Because in properties, we do a getter and a setter. Do I need both a getter and a setter for a reference type? What do you think? It's new. This is a new thing for you guys, right? You've never seen this before, maybe, or maybe this hasn't been talked to you about. Do I need a getter and a setter? What do you think? What do you think? Do I need a getter and a setter for a reference type in a property? Do I need a getter and a setter? Both. Think about it. It's a reference, right? So the answer is no. I only need a getter. If I have a getter, I'm getting a reference. Therefore, I can do something to it, right? I don't need to set something else. If I want to reset the reference to point somewhere else, then I can have a setter, right? But otherwise, I don't need one. All I need is a getter, right? So I need a private instance variable here. I'm going to take a break after this. And we know it's private. We know it's a list. Hey, did you guys do lists? You guys did lists, right? And you need these angle brackets. What do these angle brackets mean? It means type. So here I can use power as the type, right? Because I define my power class, I'm defining a new data type. My data type has two properties, right? It has a string, name, and an integer, rank, right? So here's my list, my power list. And I need a name, and I'm going to call it underscore powers, right? Okay, cool. Am I done? Like, what is this? And is there anything in my list right now? Okay. Is my list even a list right now? What do I need to do to make this list a list? I need to initiate or initialize it, right? So in order for me to initialize, I need to do it. Should I do it in my superhuman constructor? I don't recommend is the answer. And by the way, one thing I'm missing is some comments. I'm going to do the // here. This is going to be my main constructor, right? So this is the main constructor for the superhuman class. It takes one parameter, name, which is of type string. For now, we can modify this later. Cool, we got this, right? And I want to add the powers, right? This thing, and I want to instantiate it. I recommend making a private method called initialize. Hear me out for a second. So here's my private underscore initialize method, which returns void. So it doesn't do anything other than initialize. Why? Because this method initializes, instantiates, and assigns values to class properties. That's all it does. Remember, on a method, if you think about it, it should only do one thing. So that's all this does. All this initialize method will do is initialize or instantiate any class properties I need. So example would be this dot underscore powers is equal to a new list of type power, right? All right, and this creates an empty list. Creates an empty list, right? So this is an empty container. That's what it is right now. It has nothing inside of it, right? But until I did this, until I instantiated, right? Until I instantiated my list, it was nothing. It was just some memory that I put aside that said it's going to be a list, but I'm not doing anything with it yet, right? It's almost like a pre-setup. That's what I was doing. All right, but this actually, what this does, it says, hey, I want to instantiate a new object of type list, or of type power, or list, a new list object of type power, right? And power, this is cool. That means every object, every item in the list must be of type power. Okay, cool. So then I'm going to call my initializer right here. So this dot underscore initialize. So in my constructor, I'm going to call the initialize method, right? Why wouldn't I just do this in my constructor? Well, this is okay if it's only one thing, but what if I want to do a bunch of stuff? It's going to clutter my constructor. It's going to look really ugly, and that's why I'm doing it this way, right? I don't want to. I want to make my constructor as clean as possible. And I want to make my initialize method as succinct as possible as well. Okay? Besides, I have a method to my madness, and there's also another reason why I want to put this together so I can give further examples later on. Okay, so I've got my initialize method. This is nice. I've done it. That's great. And I've almost got my superhuman class, right? But I have a problem. I don't have any way of adding a new power, right? And I've modified my superhuman class. I've actually added, right, a initialize method. So that's what I'm going to do. So 0.2. Now this is where we're starting to do. I added an initialize method underscore initialize method, right? Now you're like going to say, hey, what happened to 0.1? Well, don't we want to keep track of that? Yeah, GitHub is going to keep track of that. We're going to keep track of the latest change up here. Okay, so save. That's cool. And now I'm going to go to GitHub. So I'm going to go to Team, Home, and I'm going to go to Changes. Notice I've got modified superhuman. I'm going to say inside my superhuman added initialize method to superhuman class. And then commit all. There it is. And then now if I go to home and I go to sync, guess what? I got 3 commits. Look, 1, 2, 3. But instead of having to commit each one of them or pushing one of them separately, I can just push them all together. So I'm going to push. And what this does is it pushes all these 3 commits to my GitHub repo online. Notice there's only 5 here. But if I refresh, I have a bunch more, right? 8. And it does it in order. So here's my Readme file, my human abstract class, my super class. I added my power class. Then I initialize method to my superhuman class. And I could probably put other comments in there as well. Right? Why this? Because this is a manifest of all the things that you've done, right, as you develop your code. And this might match 1 for 1 with your feature requirements that you've been given when you create your classes and your application. Okay? It's a really good methodology. Keep track of what you're doing. And you notice that on July 11th, I've got all these little commits. You might see 30 commits, 40 commits, 50 commits, 100 commits on one day. And that's OK, right? Because we can always step back. If I want to see what was added in my power class, I can click on it. And I can see that the changes that were made, right? These are the changes. Look how I changed the different settings here, right? Here's my class diagram. I actually added stuff in my class diagram, right? Here's all the stuff that I did in my power class. I actually added my whole power class, right? And what about it? What it looks like when I modify something? It looks like this. If I go back to my initialize method, take a look. I modify this. There's my version 1. There's that version 1 comment. Here's my version 2 comment. See? They're there still. I can see them, right? And here's where I take away spaces or add something. And you can see everything that's been added or removed. And that's why we do things on GitHub. You can always track your changes. OK, let's take a short break, 5 minutes for water and washroom, and let's come back and finish this up. Go. And